Okay, in this example, we're going to look at second derivatives. And I like to wait until we get to this section to do second derivatives. The book treats them a little bit earlier, but I think it's best to have actual formulas that we can manipulate because then that makes the second derivative seem maybe less mysterious. And the basic idea is this. You take the derivative once, and now you have a new formula. And you could look at that formula, and you can take the derivative again. And then we'll talk about what the graphs look like and the concavity and so on. Okay, so let's start. So f prime of x, this is just going to be the power rule applied. So the 4 comes down in front, 4x cubed minus 4, and then the 2 comes down in front, and I subtract 1, so x to the 1. And of course, usually I would clean this up and say 4x cubed minus 8x. So that's the derivative, the first derivative. Well, there's a formula. 4x cubed minus 8x. Let's take the derivative again. And the notation for this is double prime, meaning you did the prime once, that's the first derivative, and then you do it again. Okay, so the rule is the same. I bring the 3 down in front, and then I subtract 1 from the 3. So this would be 4 times 3, x squared minus 8x to the 0. I'm sure some of you are already thinking you could do this faster, and that's fine. You don't need to write x to the 0, and you don't need to separate the 4 times 3. So this is 12x squared minus 8. Okay, so now we have the first derivative and the second derivative. And what we're going to do is we will graph all three functions, f and f prime and f double prime. And we can also compare this to graphs that we looked at in section 2.2. We didn't know the formulas then, but I asked you to estimate or make a rough sketch of the graph of f prime. So I will go to Desmos to do this, and then we'll talk about that. Okay, so I did get these graphs out of the computer, but I thought it'd be easier to not look at the actual Desmos page, but rather be able to kind of draw on top of a virtual piece of paper. So so you can go to Desmos and reproduce these graphs, but I want to be able to circle things and point out to them. So so actually, let me start by making sure we're all looking at this the same way. This is the original graph f of x. That was the x to the 4th graph. And then this is the graph of f prime of x. That's the x cubed one. And then last, this is the graph of f double prime of x. So what we were asked to do is graph these and maybe look at how they line up, and also to compare them to one of our examples in section 2.2. So in section 2.2, we were given the graph of f, and it said to produce a rough sketch of the graph of f prime. And indeed, the solution I posted had a graph that looks a lot like the middle graph here. Of course, there was no way we were going to be that accurate doing it by hand, but we should have had a graph that was positive in the right places and negative in the right places, and so on. And I'll remind you what we looked at when we did that. We start by looking at places where m is equal to 0 on the top graph. So I've circled those in red. And remember that when you have a slope up above, you turn that into a y value down below. So where the slope was equal to 0 up above, you should be able to come straight down and have a y value of 0 down below. So again, slope up above, y value down below. And then we did it with a few other points too, and this is the part where, of course, we were not super careful and precise, but if you look in the middle of between two of those slope 0 places, I think we said that we just decided maybe the slope looks like it was about 1 before. It's not exactly 1, that's fine, but it's a positive number. And so it's a positive slope up above maybe we could guess something better than 1. I really probably should just remove the x and y values from these graphs, but it's a positive value, and then down below we have a positive y value. And then similarly we have a negative value here. Whoops, not 1, negative. And that should correspond to a negative y value down below. We can keep going. We could say there's a positive slope here, and that should correspond to a positive y value there. So that's what I mean by we should be able to match these graphs up. It should be positive in the correct place, negative in the correct place, and so on. Okay, we were asked to go a little bit farther, namely to look at concavity of the original graph. And so concavity means which way is it curving? Is it curving up or curving down? So let me pick a different color. How about pink? So let me go to a spot where I claim it should be kind of obvious what's going on. How about over here? So the original graph there is curving, and the question is which way is it curving? And it's curving up. If you read it from left to right, it starts by going down, but the way it's curving is to go, instead of down, it will start to go the other direction. And once it does start to go up, it starts to go up more. So it's curving up. And what that should mean, if you go all the way down to the bottom graph, is that we should have positive values on the f double prime graph. So the original graph is curving up, and that corresponds to positive y values down at the bottom. So here I would say, which way is it curving? And all the way down here, that turns into a y value. Let's look at another spot. Let's look in the middle. The original graph in that area is curving down. Now it's going up, but it doesn't keep going up. It wants to keep going and turn around. So it's starting to turn around, and then eventually it is going down. The whole time it's curving down. One way to put this is it's curving less upward, or it's starting to turn around. Okay, so that's the way it's curving, and if I go all the way down to the bottom graph, what that should mean is negative y values. So curving up means positive second derivative, and so that should be positive second y values on the second derivative graph. Curving down means negative second derivative, and so that should be negative y values on the bottom graph. One way to remember this, also just like what the shape of the graph is, up rhymes with cup, like you could fill it up, and down rhymes with frown. So if you're trying to remember which way is concave up, it looks like a cup shape, and which way is concave down, it looks like a frown. So CU for concave up and CD for concave down. And again, I don't expect that we can do this very accurately just by looking at the pictures, but we can tell that the pictures are correct because they go up and down at the right places.